Hello, what's up guys? Charles here from Driver Studio, and today's tutorial will be about Luxcore render engine as always, but today we will discuss engine settings. You know what? You know how to set your shader. You know how to do some lighting in Luxcore, and now you are stuck in a pretty dumb place, a pretty hard place. You don't know how to make the configuration of your engine the more efficient possible. You don't know why Luxcore have all those bunch of settings and that you don't see in cycle. If you come in cycle here, you see there are just this. You set the number of your sample, you just set the path. You can even let this, because it is normally great for any kind of render, and it is just this. You don't have any setting performance here, just to set the till, and you don't have many settings to care about. But you come in Luxcore and you see light path, you see CPU, OpenCL. Yes, it is nice, but you see also you have path, you have bidirectional, you have performance, but yeah, you have pixel filter, light strategy, and you have the caches, and under the caches you have many settings, and you feel that, oh my god, you are not going to learn and to understand this engine anymore. So you want to give up, and you say it is pretty good. So you see people do some nice render with it, and you want to learn. So you want to overcome all those obstacles and learn the engine. So let me tell a secret. At the first glance, Luxcore can look very hard and very complicated, but in reality it is a pretty simple engine, and let me tell you how it is simple. So let's start this tutorial. So the way to see Luxcore is this way. So in normal life, and let me compare Luxcore to car. Okay, you have your raw model coming from the manufacturer, so let's say Mercedes, and you have the normal AMG car, the normal Mercedes C-class car, and you have the one called Mercedes C63 AMG. So it is the same model, but with some tuning and more, some button and some feature inside to make the car faster on the road, but also even faster on the track. So Luxcore is like this. It is like your normal engine, let's say cycle or annual render, but with some feature inside to make it faster. The reason is that because the render equation is pretty hard sometimes. So let's say sometimes you want to render diffuse material, so there is a configuration to go faster. Sometimes you have to render some glossy material with some caustic, and maybe you want to have a setup for the case where you have many lights in your scene. So a render engine have to adapt to many different kind of scene to be able to be faster. Okay, this is the reason why you can see all those parameters, all those setting and feature inside Luxcore. It's like a normal car, but with more setting, more feature to make it even faster. So you will be faster with Luxcore if you know what you are doing with inside that setting. So let me tell you. The first setting you encounter in cycle, the first difference is here with the device. So you can switch between CPU and OpenCL. OpenCL means GPU rendering most of the time, and hybrid rendering, so you can mix your CPU and your GPU to render the same. Okay, simple like cycle. But and now you come to the engine path. So you see path and you see bidirectional engine. So bidirectional engine is another way of computing light in a render engine. Currently it is a bit deprecated render mode, so we're gonna talk about path, because as the development of the engine goes, so path become able to do the work of bidirectional engine. So most of the time you don't have to worry about bidirectional engine, so stay on path rendering. Okay, you also have this feature here called use cycle setting. So the developer want to help the new user to get they fit well inside of the engine, so they add this feature to import your setting from cycle. But from my experience, it does work from some setting but not for all, so I will skip this and let you know what is really inside of Luxcore. So the first big settings you come with in Luxcore is this one, the light path. So by default, all light paths are set to 4 for diffuse, glossy 4, and total path 6 and specular 6. Okay, so let's explain this if you maybe don't know. If you are in cycle and you know this this one light path, it is the same setting and the same behavior. Okay, so let's come to Luxcore, and you have 666. Okay, so every shader inside of the render engine are treated differently, independently. Okay, so let's say the less light boons, this setting are here for light boons. The less light boons you are on inside of your scene, the darker the scene become. Okay, because light, in reality, light boons thousands of time around the scene and come to your eye, so you see bright walls, bright object everywhere, because light boons very often. But in a render engine, we cannot allow us to make thousands of bones, so we reduce the number, we simplified the number of bones here to have exactly what we need. Okay, so for the diffuse you have 4, and for the glossy 4, and the specular 6 bones of light. So these settings are almost good for most of the scene, but particularly you will see that there is a something here. So let me show you. I have a glossy ball here, a metallic ball, a rough glass here, and I have a complete glass, a normal glass here. So let's say we set the total path. This one act like a limit, so let me set the limit to 1, and you see my scene become completely dark. Okay, so what does it mean? So this setting is here to cut every light boons. So by setting total path to 1, I am making everyone here to 1. Okay, if I set my total path 2, I am making everyone here 2. So instead of 6, this will be cut to get to 2. Okay, and let's say I go to 5, then you see every setting here is not going to be 5. The diffuse will stay at 4 because it is under 5, the glossy at 4 because it's under 5, and the specular will be cut at 6 because it is above. So if I want the specular to be set at 6 during the rendering, I need to make here 6 or maybe even more. But if I tell the engine here to say 12, I will not have a bounce light here, any light bounce and to go to 12, because 12 has act like a limit here. So everyone will stay at 4, and 6. Okay, but if I set here to 16, then 16 will be set back to 12 inside of the render engine. this is all for here. So for most of your render, the diffuse will take care of the wall. In my corner box here, my matte wall will get the diffuse. So if I set the diffuse to 1, so you will see that all the matte surface here become darker, but the rest of the scene stay almost the same. And you also have your glossy, and the glossy, if I set my glossy to 1, you will see that my rough glass here become darker, because glossy will be applied to rough material. So as soon as you switch from glass to rough, then glass are not controlled by specular bones, but they are controlled by glossy. So if you have a rough glass inside of your scene, make sure to have the correct bones here. Okay, so if you want to have a good looking rough glass, you have to set this number to a bit higher number, and for your specular glass you can set it to 12. So, and this is it for this part. Okay, then you can launch your render, but let's say you want the render to be even faster, okay, and to have some other feature like caustic. Then Luxcore give you the tool. Let's say we have 2 glass here and we want the caustic, and if you hide the 2 balls, the metallic and the glossy ball, you see there are some caustic happening here by default. Luxcore is pretty precise, so it is able to generate caustic even if it is harder to do that. But as you can see, these caustic are slow to get, okay, they are noisy. So let's say you want your caustic to be faster, okay, you want to generate fast caustic. So there is an option inside of Luxcore to generate fast direct caustic. So it is called add light tracing. So you check this box because you have glass in your scene, and because caustic is pretty visible in your scene, you want this caustic to be to get enough power. So you check this box. So these settings is here to make the engine use a bit of your CPU power to compute more precisely your caustic. So you have this light ray setting here in percentage, and this one is here because we are in CPU. You get the same setting even if you are in OpenCL, but this one is here to tell your engine to use the power of your CPU, how to set how much power you have to give to the caustic. So you have inside of the render, you have to compute the diffuse, the light, and you have also to compute the caustic. So you say 20% of the power of my CPU, because you are in CPU, have to go to compute the caustic. And you have the second settings, it's a glossy threshold. So for every it is a glossiness threshold, if a material roughness is lower than this threshold, it is sampled from light. Otherwise, it is sampled from the camera normal path tracing. Okay, so light tracing work in the reverse of the normal path tracer. So if you have a material with a glossy threshold above 0.5 or same as 0.5, then you will not got caustic well computed with this light tracing. So what to say, if you want caustic here. So let's select our ball here and check what is done here. So as I can see, the roughness here is set to 0.2, so I am not in the range of the caustic. So let's say I am completely down, so you see I have very fast caustic, and at the time I set it to almost 0, I get instant caustic. So I can go back and forth, and you see caustic are instant. Okay, so if I go back, disable light tracing and render again, you see I don't have the fast caustic I have at the beginning. So let's go back, and you see I have fast caustic. So if I want my glass to stay blurred, so and I want the original setting to be at 0.2, so and I want the light tracing to compute the fast caustic here, so I have to increase this number here, so 0.21. so you see the caustic are really computed very fast. Okay, so I include every surface with height roughness level with this setting. Okay, then you have another setting inside of your render engine. It is the clamping settings. You have the same here in cycle. If you come in the light path, you have indirect light sampling and clamping and direct light clamping. And Luxcore currently we don't have a separate channel for direct and indirect clamping. We have variance clamping, so you check this box, and all the noise in your scene will be removed magically. Okay, the fireflies, it is the fireflies remover. So inside of most of my scene, most of the time, if I don't have caustic, I start with something like 5, so I remove all the caustic, all the fireflies inside of the scene. But when you have some caustic, you have to be careful. I still get the caustic. Okay, I still get the caustic, so but my class here become darker because the number is too low. Okay, so I have to increase this number to something like 10 maybe. So I need more. Okay, so as the render goes, I will get the fireflies removed, and I will get the light inside of my glass back with these settings. Okay, so this is all for this part, and we fall in we also have this part, the advanced one. So in this advanced one, you have two sampler. You have the Sobol sampler, and you have the Metropolis and the random sampler. Okay, you don't have really to worry about Metropolis and random. Most of the time you need Sobol. Metropolis are here because of mostly because of bidirectional, because bidirectional engine work better with Metropolis. So when you switch to bidirectional, maybe you want to make some scientific experiment and you know what you are doing, because bidirectional will be maybe for another tutorial. If you switch to bidirectional engine, then you have to switch to Metropolis. So most of the time you have to stay on Sobol. Okay, you don't have to worry about this one. And let me say that if you switch to bidirectional is only supported by the CPU, so you don't have the fast OpenCL GPU acceleration. This have to be noticed. But now let's say you understand that you have to be in Sobol, and you have this setting here. Those settings here are here to make your render engine to be efficient and adaptive during the rendering. About noise, okay, and you have the first setting about the adaptivity strength. So 0.5 mean 50% of the adaptivity of what. So let's say I want to render this scene. Okay, I launch the scene, switch to render result, and you see I have the rendering. Okay, I let the render goes before I hit the refresh, and you see we have some part of the image that are very noisy, and we have some part that are not too noisy. Okay, what is that? So you see we have this red flat wall and this green flat wall that are not too noisy, and we have a lot of noise here, a lot of noise on the ceiling, and not too much noise on the glossy ball and on the metallic ball. So this setting is here to help your engine to allocate more power to the surface in your scene, the area in your scene that are noisy. So if you set to 50%, so the engine will focus by 50% on the noisy place. So most of the time I go aggressive, I set it to 95%. So I want most of my power to be allocated to the noisiest part of my scene. Then I have the warm-up sample. So this setting is here to tell the engine at which moment it should start to run the adaptation code. So 8 means that the engine have to wait for 8 cleaning sample, and when there's 8 cleaning sample happen, the engine take this image with 8 output image and learn from this image and make the adaptivity. So the adaptivity will start at 8 sample, and then you have the test step sample. Okay, it is said that this is how many sample to render between conversions test. Use smaller value if your scene render very slowly, and higher value if your render is very fast. Okay, so if you have use smaller value if your scene render very slowly, and higher value if your render is very fast. So what does it mean? It means that after the warm-up sample you have here, you have your test step render. So the engine will calculate another step of sample, and if your render is slow, as the tooltips say, you have to use smaller value, so the engine will adapt a bit more on noisy surface with low number. And if the rendering is pretty fast, so you get noise cleaning very fast, so you have to use higher number, so you get more benefit of this. Okay, but most of the time I don't go very higher, so I get this to be 8. Okay, and I start to get pretty good result with this value. So don't forget we are still on CPU. So I have 21 sample, so the adaptivity starts and the engine will update where the engine will have to allocate more power in the scene. So this is all for this part, and we also have this part. It is set to light strategy. Most of the time you don't need to change this one because it is adapted to most of the scene you will have in your scene. So you see that with adaptivity we get pretty nice result compared to the first one. Okay, and okay, I come to light strategy, and it is say log power, power and uniform. Okay, uniform, it is the behavior of cycle. So with this setting, you treat every light with the same power, so every light will be treated equally. But in reality, this is not the case, because you have maybe the light coming from your HDRI, which is pretty bright, and you have a small artificial light inside of your scene of your bedroom, and this light don't contribute a lot to the lighting of the whole scene. So you need to allocate the power to the more powerful light. So you need a light strategy to tell to the engine which light need more power and which one need less power. So the log power work for most of the case where you have HDRI and some small light around. So most of your interior arc-vis scene will be good for this one, and most of the scene also where you have a environmental light plus some small light. And in case you have a more simple scene, maybe it is a product based scene, you don't have any environmental light, you have some light panel like some area light, some spotlight, then you should switch to power. So this one is more suitable for this kind of scene, and it makes sense here. But most of the time, please stay on log power. Okay. The next one we need to cover is the pixel filter is not very important, and here you have the performance. So this means how many CPU thread you want to render. Maybe you want to do something else, so you switch to fixed and you reduce the number, so you have some CPU thread to do other work. Okay, this is it for this one. And you also have tail rendering here. So bear in mind that not Luxcore don't have the same behavior of cycle, so you are not going faster if you use tail rendering. Okay, you have to bear this in mind. So most of the time you will need to use tail rendering if you are rendering pretty large image, so let's say 8K or 10K image, and you want to be efficient in memory, so you want to use tail rendering for that. So most of the time Luxcore is faster in the normal progressive rendering, so you don't need to go to tail rendering to get more performance like you do in cycle. So then you have the denoiser of Luxcore, which is in this part. So if you want the denoiser, you check this box, and you have Intel image denoiser by default, and the memory that you want the denoiser to take. So if you don't have too much memory, you can tell how much megabytes you want the denoiser to take to make its computation. So most of the time Intel image denoiser outperform BCD denoiser, so I tell you to stay on this one, and maybe to reduce the max memory if you don't have more RAM inside of your maybe laptop or your desktop. So this is all for this part, and now we are in the Luxcore display settings. This one is here to tell to the engine how often the engine should update the rendering. So at the start you get some updates, some progressive fast update, but after that you see then you have film refresh, and it counts 2 seconds, 1 second, and update, and then you have to wait 10 seconds before you get the update. So if you want the render to update more often, maybe you switch to here 1 second, but you see that I have refresh interval here it say 5 seconds. This is the limit, and you see that here it is 5 seconds also. It is the same setting you have here. So I just press the N button. So let me just enable screencast again. I always forget to check this one. Okay, so the same setting you have here by pressing N and go to Luxcore. It is the same setting you have here. Okay, you can also refresh your image during the rendering by just clicking here, refresh, and it's refresh. Okay, this is all for this part. And you also have the Luxcore Viewport setting. This is for the render engine. Maybe you have your engine here, you have your denoiser set, and you have to wait 10 seconds before the render engine stop to calculate, to compute the light inside of the viewport. So if you don't want more computation time, so you have to switch to 1, so you get pretty fast update. And because I have the light tracing, because light tracing compute from bottom to from down to up, so I have the black band here. So if I disable light tracing, I have the normal behavior. After 1 second I get the denoiser. Okay, you see, after 1 second denoiser. Okay, if you want to have more calculation before you get the engine to stop, so you have to increase this one. Maybe you can put it to 16, depend on you. So this is all for this part. And now we have another setting here. It is advanced, and you have something here, block size, and you have the pixel size. And tell you to really not touch this one. But you have this one also 8, and you see this is what happened. And this is what happened when you switch to 1. And as you can see, these settings is here to tell the engine to compute. By setting to 1, you are computing your normal scene with the normal resolution size. But as you go to 2, then the engine start to compute half the resolution of what you are seeing on the screen. If you switch to 4, so you get a quarter of the resolution, so the render become blurry. Maybe you need that to speed up your viewport, but I don't use it most of the time because it is not very precise. So most of the time I stay on 1. And you have this one, block size. Most of the time you will stay at 4. But if your hardware are not very strong, I tell you to go from 32 to maybe 16. So what does it mean? So at the beginning of the computation inside the viewport, the first sample of your scene will be computed with a very low resolution, and the next step will be computed with the right resolution. So this helps the engine to be more fluid when you turn around. And it is very important when you are in CPU, because currently there is a small issue with the engine. So what does it mean? I mean that in the viewport rendering, currently Luxcore frame rates and Blender and display frame rates are coupled. So the developer said that this make the viewport a little bit unresponsive. So this issue is currently addressed by that and BioB, and all the developers, so this behavior will be less visible in the next time. Okay, so this is all for this one. So this first setting is here for to tell how much how height the resolution will be for the first sample of your scene to make your viewport a bit responsive. So most of the time I tell you to stay on CPU when you are doing viewport rendering, because CPU is a way fluid and soft compared to OpenCL rendering in GPU. So because the GPU have to update and compute the display of your screen at the same time, but this will become more powerful, more performant in the next month. Okay, so now we have covered almost all. Then we come in the Luxcore halt condition. So let's say you don't really know Luxcore and you start your first render and you see that Luxcore never end because you don't tell Luxcore to stop. Where to tell Luxcore to stop? It is here, Luxcore halt sample. This is here for final rendering, not for viewport rendering. So maybe you want to use sample to set, or maybe you want to use the time. So you can use the time. So you tell Luxcore to stop the rendering at 10 minutes, or maybe you want the render to stop at 1 minute, or maybe at 2 minutes. So this one is set in second. Or maybe you want to use the simple halt condition. So you check this box and you say Luxcore, please stop after 500 sample. Okay. Or maybe you want to use a noise threshold, so you tell your engine to stop at a given noise threshold. Okay, you have some warm-up sample and some test sample also, but most of the time don't complicate yourself, your life, so stay on use time or use sample. It's good. Okay, then we come in the performance part. So I tell you at the beginning that Luxcore is like a racing car and track car, and you have some setting here to make you perform depending on your track condition. So you have you have some rain on the track, so you go to Caustic, this analogy. You have some caustic, you have some glass, so you have to enable add light tracing. You have some parts of your scene that are rendering faster than other parts, so you have to use the adaptivity. Okay, and you have some parts of your scene that are pretty diffuse and you see that they are noisy and you want them to go faster. What you need to do is to come here. Luxcore have a feature that I really like, and it is called Luxcore cache, Luxcore photon GI cache. So let's enable this and test a render. For those who don't know this feature, it is like a feature you have in Vire and Corona, and this feature allow your engine to be pretty fast when it comes to compute light on matte surface and diffuse surface. So as you can see, after only 12 seconds, our render is cleaner than the first render that took 1.13 seconds. So in just 12 seconds we get almost clean walls. Okay, so you see that the parts of the render that take most benefits of like caching, photon GI cache, is the diffuse part of my render. Okay, you see the wall are cleaner compared to the first render. Okay, here this is the first render with the noisier wall, and here the 24-second render compared to 1 minute 30-second render. So you see that the wall are cleaner, but the glass are still noisy. Okay, so light cache is here to speed up your render using a technique called light caching, and to speed up all the places that are mostly diffuse. So let me explain you how it works. So you have this feature which is very important in Luxcore. It is a feature you see in engine like Redshift, Vere, Corona, and what else in Luxcore. Okay, so let's talk about it. So let's talk about it. So you have this feature is here to compute a light map to tell the engine where the light is and how much shadow and light are distributed inside of your box. So let me show you how the light look like, so the map look like. So you come in this one and you say, instead of show the final render, show me the indirect map you computed. So I render again, and we see we will get a map, and you see this is the map of Luxcore, the photon GI map. So you see that we have some pretty low resolution light map here, and you see that we have the shadow in dark, and in black you see the part of the scene that are not included in the map, so this part will not be accelerated by the photon GI cache, but all the part you see here in green and red and with the map will be accelerated by the light caching. Okay, so this is how the engine works. So we have a blueprint that is used by the engine to start the render faster. Okay, so how to make this one faster? Okay, so you have the first setting, which is called photon count. So this have to play with the size of your scene. If your scene is pretty small, you don't need too much photon inside. So for this small corner box, which is around 4 meter by 4 meter, I need something like let's say 2 million photon. It is a small scene. If I have a big room, a big gallery room, then I should go to 20 million, maybe 40 million. If I have a big library, I should go to 20 million, for 40 million. But if I have a little bedroom, so something like 2 million or 5 million maximum will be enough. And I have the photon GI photon depth. Okay, so let's see how it look with the photon count set to 2 million. Okay, you see that with less photon we still have a good map. So okay, we have less photon but we still have a good map. So you don't need to have higher photon count here. So if your scene is smaller, please go with a small value here, and remember that the value here is set in millions, so you don't have to go crazy with this number. Okay, then you have the photon depth, which is set by default to 8. So the higher the value here, the brighter the photon map will be, so the scene will be brighter. So 8 is a value that works for almost all your scene. So let me show you how it works. So if I tell my photon to be the cap limit is 3, if I tell my photo map to be depth to be 3, so you see it is darker compared to this one, which is 8, brighter, darker, brighter, darker. Okay, so most of the time you will have to stay on 8, maybe 12 or 16 if you have you want to have a very big quality, very great quality, but it is not necessary. So because you see that it is not very bright compared to 8, so 8 is a good number. So let's say we want 8 for this scene, and you have here another setting. So you have, I'm talking you about the most important part. So we have the brute force radius scale. Okay, at the beginning I told you that Photon GI cache work with a map, and it's work better with diffuse surface. This is the reason why you see inside of the scene that all glossy and metallic and refractive specular ball are not included in the map. But one guy is included in the map. It is this one. Okay, it is the metallic ball. So why is that? The reason for that is because the roughness of the metallic ball is the same as this one, the glossy threshold. So if the metallic ball is under the glossy threshold here, you will see that the metallic ball will never be included inside of the map. Okay, why it is we use this glossiness threshold? Because light caching technology, light caching feature is not very precise when it comes to very reflective surface, so you have to be careful. So most of the time this value is enough, so you have to let it to 0.05. so all surface that are at the same level of roughness 0.05 or above will be included in the map. All reflective surface under this value will not be included in the map, so we avoid to get some wild behavior. So the reason, so after a particular surface or shader get excluded of the light caching, which mode this part will get? This part will simply be calculated by the brute force. This is the reason why we have this setting, brute force radius scale. The higher this value is, the more brute force you have inside of your scene. By default, this setting is set up to 8. So let me show you the brute force radius map. If I render, we'll see. Okay, so you can see that we have some a different map. You see we have a red and blue surface. Why is that? So for any space, for any area you see red, this means that this part is computed by the brute force, and for any blue part you see that this part is computed by the light cache. So this means that if you want more speed up from your light cache, you have to make your scene to be compatible, so you can use lower number, so less reflective surface, and you reduce the brute force. So let me show you. We reduce the brute force scale, then you see we have more blue parts inside of our scene. So all the parts that are in the so you see here the scene is almost reddish, and here we have more blue inside of the scene. So this is the brute force radius. So this one is here to tell how much brute force you have inside of your render and how much leakage you have to compute inside of the scene. So by reducing this value, you get a lot of performance, but also you are mostly in some area where you can get some kind of error. Okay, so if you don't get error, so let's see, so you can stay at 1. Okay, let me see. With brute force set to 1, the render will go faster and we don't have any light leak. So in this kind of situation, I can stay with 1 as a brute force radius. So you see, this is almost all for this part, and you have also a caustic light caching. Okay, so at the beginning we say that we have already a setup for this, for caustic, and I told you that this one was for direct caustic, so for caustic that travel directly from the light inside of the glass bowl and are directly seen on the any kind of surface. Okay, and this caustic light cache is mostly done for a special reason. So let me show you something. With light tracing enable, let's come inside of the ball. Let me change the view so I can go inside of the kernel box and render something. Okay, so we have our light tracing that is computing our caustic here, but if you look closely here in the ball, we don't really see the caustic here. They are not really visible inside of the ball. The reason for that is that if you need the caustic to be visible inside of a reflective surface in your render, so you need another kind of engine. This kind of caustic is called SDS path. So this one needs some different kind of engine. So let me show the kind of caustic. So SDS caustic, and this is the reason why I have done another video about it, another tutorial about it. Don't see why I look like the connection is wrong, but okay, let me show you. Okay, let me add a new collection and hide this one, add a simple surface, add another surface here. Okay, so you have your, so let's say you have a flat panel here. Okay, Okay, shade too smooth. Let's say we want this one to be metallic, so we go for the okay, metallic ball, and we add a light, area light. We want some caustic, so let's make this area light to be small 0.1. Okay, and let me duplicate this ball here, and okay, we have this ball here, so we get some caustic. Okay, so I put my light here, make it very strong. Okay, and let's see. So as you can see, let me change this one to be more reflective. So you can see in the mirror surface that we have the caustic from the ball here, directly seen. We have the caustic from the mirror. You can see some sharp light coming here. Let me make this one darker so we see the caustic easy. Okay, and let me make this one brighter. So we have the caustic of the mirror surface, we have the caustic of the ball, but if you look inside of the mirror, you cannot see the caustic on the surface reflected inside of the mirror. This is the kind of caustic you get with a pool. Okay, when you have a pool inside of your sand, this is the kind of caustic you have inside of the pool. So if you look closely inside of the mirror, you don't see the caustic shape on the surface being reflected inside of the mirror. Okay, this is the reason why you have this caustic linkage. Okay, I have a tutorial on this caustic linkage where I use this caustic linkage to teach you how to make a pool with some caustic inside, because inside of the pool you have the light coming from the outside and going through the water and hitting the pool ground and bouncing around, bouncing back to your eye, but the caustic have to be reflected on the surface of the water so you can see the caustic and inside of the pool. So for this kind of caustic, you need caustic linkage. If you have some direct caustic like we have inside of this sand, like this, then you need light tracing. If you have some reflected caustic, then you need caustic linkage. Okay, so if you want to understand more of this cache, I tell you to go to the caustic pools tutorial I have already made. The next parameter we have, it is environment linkage. This one is used to, this is the portal light solution of Luxcore. This one is for indoor sand with a narrow window. If you have an indoor sand with a small opening window, so you need some portal, and portal in Luxcore are automatic. You do not need to add some kind of area light inside of all your window to have portal. So you need this one. So if you check this one, you get portal enabled. So this one is for interior scene where you need portal. Okay, this one will help the engine to compute the light from the environment light and directly get through your window. So this is for the light quality, so you can set it to 1 and you get the maximum quality from it. Okay, this is all for this setting. You have to check it if you want portal, and you can save the computed map so you don't have to compute it again and again. You can also save the like-ish map. You can see that here we have compute and save, so the map will be stored so you don't have to compute again. This is very important for still image, but and also important for animation where only the camera is moving. But if you have an animation where your light is animated, so a sunset, a sun animation, or a light where any scene where your light is animated, this will not work very well because the first map you compute will change because your light is animated. So you can also make your environment like-ish persistent by enable the environment like-ish and make compute and save also. And this is all for this setting. And there is another one. It is called direct light sampling cache. You should not use this one often because this is for scene where you have multiple light source, like where you have a lot of small light source everywhere, like in a city by night or in a Christmas tree, en tout cas, I'm speaking French now. For every scene where you have a lot of small light source, then you should enable this setting. If you enable this direct light sampling cache, you have to increase this value, the warm-up sample. Don't worry about the advance. If you have a pretty big scene and you want the direct light sampling cache to be very precise, and you want to get rid of some black spots inside of your rendering, so you have to increase this value maybe to from something like 12 to 64. Okay, so you get more and more precision from the direct light sampling cache. If your scene is big, you have a lot of light everywhere, so maybe you will have to increase this one. But if you have a simple scene with a small Christmas tree and some light, maybe 64 is enough. So for some smaller scene, 12 can work. So you have to guess if you have some dark artifacts inside of your scene, you have to increase this one and it should work. But use this only if you have a lot of multiple light source inside of your scene. Another thing, this is the last one because the tutorial is finished. I hope it is not too long, but I'm sure it is because we talk a lot. And the last setting I want to talk to you, the last performance setting, is in light. So when you have a light inside of Luxcore, you can see you have the gain, which is mostly the power of your light, and then you have here inside performance, you have here importance. So sometimes you have in your scene, most of the time you have different kind of light. Here I have two light source. I have this big light source and this small light source. So let me go back in the scene, and this importance setting is here to tell the engine which light source need more computation power. So this one will help you to be even faster. If you you set maybe your this is the big light here. If I set it to 0.01, you see that the scene is noisier because this light source is the most powerful here. This light source give the scene most of the light, so this light source must be computed with more computation power. So I set this light source to receive more computation power. So you can see that I get rid of noise. So let's say I have inside of my scene an HDRI. So let's add an HDRI from HDRI even. Let's add an HDRI. Yeah, maybe this one. So I have my HDRI and I have my let's say let's disable the light tracing and come back to the HDRI. Okay, you see that my HDRI is very powerful than my artificial light source, so I should add more importance on this one. Okay, and you see the time I get more importance on my HDRI, the engine gets cleaner faster. If the number is low, you see that there is some noise, but if the number is higher, you see that we get rid of noise faster. So according to the contribution to a light inside of your scene, you will be able to tell the engine which light source you want to be sampled more often than other. So if you don't know, if you don't want to have to set this, you probably want to let it to 1. But most of the time, let's say you have a scene where you have some small light source, maybe you have a big room and you have a small dot of light inside of maybe a computer power button, and you have a small LED light on a computer inside of a big room. So you don't need to give to this small light source one importance. So you want to reduce the importance of this light. So by setting this small dots inside of your room to something like 0.01, so you help the overlight inside of your scene to get more power. So this is the last thing I want to talk about. I hope you enjoyed this tutorial. I know this was a bit longer, so thank you for watching and see you the next time.